Okay, before we start learning C programming, so let me tell you one very important thing. Programming is something that cannot be learned just by reading theory or just watching some pages. We have to write programs, right? So the only way to learn a programming language is by writing program in it, right? And that is what we are going to do. So in the tradition of computer science, when someone is new to the world of programming, so the very first program that we write is the program generating the output hello world. So this is the program that we have written in our last session. So we'll try to understand this by rewriting this once more. So for writing this program, we need editor. So this is my editor area where I have written this program. The return type of main is integer, and the main function does not takes any argument. So for that, we are mentioning void over here. And this printf is a function again which prints hello world. Now this is the code that I have written in my editor. Now I need to compile this because my computer cannot execute this directly. So here I'll be compiling this one. So my compiler cc, and my file name is hello.c. So if you just put the ls command, so you can observe here my source code name is hello.c. So in order to compile this, I'll write cc and hello.c. If the compilation is successful, then the executable code, the file, the file name of the executable code will be a.out as mentioned here, that after you put this command cc and then hello.c. Once the compilation is successful, so if nothing is wrong in this, in that case, a.out, which contains the executable instruction, will be present. And once we execute this, that is current directory dot slash a dot out. If I hit enter, this is the output of this given program, right? Now we understood that how can we write the program, how to compile this is the command, and how to execute this one. But what if we make some mistake? Let's say if I miss out the semicolon, and if I try to compile this once more, see, if I execute this one, then it will execute my old successfully generated file, right? But if I try to recompile this one, so in that case, I'm going to get error. So you can observe here, expected semicolon, right? So this is the error. So if you do not make any mistake, the compilation goes silently and the executable code is generated. But if there is some error, then you are going to get error message from the compiler this way, right? Now, let us try to understand the meaning of this particular program which we have written. Now, you might observe here that here int is not written, void is not written, because in the original program, that was the book that was written by Dennis Ritchie, in that this int, in that version the int can be skipped. But in modern version of C language, this int, we are not allowed to skip it. For example, if you want to skip this part, they will not allow that, because the modern compiler requires that you must mention the return type of the main. So if I clear this and try to compile this again, so you can observe here the return type defaults to integer. So in functions, if you do not mention the integer return type, then it defaults to integer. So we'll talk about this in more detail in the chapter of functions. All right. So we have observed this very well, that first we create the source code, we name the file as filename.c. Then once we compile this, if the compilation is successful, then we get a executable code with the name a.out. Now, what if I do not want this a.out name, the default name? I want the name of executable as per my choice. So in that case, I'll compile it this way. So first of all, I'll store it back here, and here I'll write the compiler name, that is cc main.c, and I'll mention the output name that I want with, sorry, my file name is hello.c, by the way. My source file name is hello.c, hello.c, and here output name. So let's say I'll give it hello. So in that case, my executable code will be generated by the name hello. So in that case, I can write dot slash hello. So whenever you need to mention your own name, then you can put this command actually. That is option O, that is output, and I want my file executable file name with the desired name, right? If I do not put that command, then the default name for the executable is a.out. I hope that should make sense to everyone. Now, so as of modern ISO standardization, the main function has to be written in this particular manner. That is, the return type must be mentioned integer, The function name must be main because every C program begins execution from the main, and this is void. So void is written just to show that this main does not accept any argument. So as of 2024, these are the two different main functions that are allowed, and this is used for command line argument. So argc and argv. So about this command line argument, we'll discuss in more detail in our upcoming sessions, right? Now, so here integer represents the return type, the main is the function name, and void means the function does not takes any parameter. And the next version of main is used for when we want to accept command line arguments. So about this we'll definitely talk later. Now this is one more program written, so I would encourage everyone that you write this code by yourself and observe the output. So this is written according to the standard C that was shown on the documentation of this particular slide, right? So this program, when executed successfully, this will print hello world, and this slash n represents a new line. So this will print the new line character for it. Now we'll talk about the basic building blocks of any C program. So a little bit of explanations, right? Now every C program, whatever is its size, it consists of functions and variables, right? So functions, you can think of them like mathematical functions, and variables. Now, so function contains statements, and statements performs the computations. Whatever statements I'm writing, it performs computation. For example, I can write something like this. Let's say integer x, where x is a variable, and here 2 times, let's say 9. So this is a statement. This statement perform a computation, right? So function contains statements, and statements performs the computations that has to be done. Whatever computations are done, now these computations results has to be stored in some intermediate memory locations, and that is nothing but variables. So variables store values during the computation, right? Now, out of all the functions that we'll be creating in our upcoming discussions, there is a special function called main. So main is special in our program because every C program begins execution from main. That means it's very clear that whenever you want to execute a particular C program, it must contain main somewhere, right? Now, so main is the function which usually call other functions. For example, like in this case, you can observe this main is the function which will call this, which is calling a library function printf, and this printf is declared in the header file stdio.h. I'll talk about this header file, and this takes an argument, that is string argument hello world, and it is printing it out on the console, right? So main is the function which is calling some other function like printf over here, right? Okay, so now we'll try to describe the lines that we have written in our program. Now, if you observe this particular line, that is hash include, and within the angular bracket, we have written stdio.h. So .h is for, this extension is for the header files. So this informs the compiler to include, actually inside within the compiler driver, we have a software module called preprocessor. So within the C compilation tool chain, the first program that comes into the picture is the preprocessor. Anyways, we'll show step by step procedure that how entire compilation system is working behind the scene, but for now, on a broader perspective, I'll say the word compiler. So this particular line tells the compiler to include the information about the standard input and output library. So this line appears at the beginning of at almost all sort of C source file that you will observe. Now, this is a brief explanation. So if you observe this particular line, this will include the information about the standard library. So as you can see, this function printf, in order to inform the compiler that you want to use this particular function, you need to mention the declaration of this one. So the declaration of this printf function is available in this header file. Later, while at the linking stage, we'll talk about linking stage as well. The code of printf will be attached with your source code. What I mean by this, when we'll observe the compilation toolchain, you will understand what I'm trying to say. This main function. So main function is this one which I'm talking about. The return type is integer and it takes void. But in the Kernighan and Ritchie's version, they simply write main. That is also valid again. So this defines the main function that receives no argument. So in order to represent this, that the function does not receive any argument, we mention void over here. The next is the braces. So any function is always enclosed within the braces. So within the braces, we can mention the statements, right? So braces defines the the start of the function and the end part of the function. Next is the printf. So this represents a function call. So a function call consists of the function name, and within the parenthesis we mention the argument. So here the main function calls the library function printf. Why I'm calling it library function? Because this printf is something that I have not written. It is the part of the standard input output header file. And this within the double quote we have the string here. Within the double quote, this sequence of character, this is called string. So this will print hello world, and this slash n is for the new line. For example, if you want to observe the effect of this new line, so what I'm going to do, I'll compile this once more and execute it, and you can see the effect of new line. So you can see hello, and then new line is printed, and after that world is printed. So this is the effect of new line. So by character it appears that there are two characters, but when executed and printed, it is considered as if you press your enter key and get a new line. So that's the slash n character. Now, so whenever we are calling function, we are passing arguments. For example, when we are calling this printf, we are passing the argument. So here hello world slash n within the double quote is the argument to the library function printf over here. So I hope that should be clear. And this braces, if you observe the open and close brace, this defines the body of the function. This particular structure defines the body of the function. Now you can observe here that the statements of the functions are always enclosed within the braces. So you can observe here that there are two statements, and this is enclosed within the braces of this particular main function, right? And the main contains right now only one statement. As per the given program, I have just added one statement here, but in this particular snippet, if you observe, it contains only one statement, right? So that is the printf statement. Okay, now how a function is called. So function calling is something that I've already discussed about. So printf is the function name, and we are passing the argument within the double quote, that is the string. So printf is the library function, right, which is the part of the standard input output header file. So that prints the output. So in this case, whatever string I have written, for example, instead of hello world, I can also write a b c d e f g and let's say slash n. So in that case also, if I compile and execute, so you can get the desired output over here, whatever modification you have made to the string. Now, so printf never supplies a new line automatically. What does it means? For example, if I'm writing, let's say, line 1 over here, and in the next line, let's say I'm writing line 2. So in this case, if you observe, the printf will not provide the line automatically, the new line automatically. So if I execute this, so you can clearly observe line 1 followed by line 2, and even my this terminal command also comes in the same line. That means the printf does not produces the new line automatically. You need to provide the new line, right? So when you are using characters like this slash n, this kind of sequence of characters is called escape sequence. So if you observe this slash n, visually it appears that there are two characters, one is slash, another is n, but it represents a single character only. So such kind of character combination is called escape sequence. So escape sequence like slash n provides a general and extensible mechanism for representing hard to type or invisible characters. For example, if you press, if you just write the character slash t, so this is used for tab space, slash b for the backspace, slash, then slash quote for double quote, and double slash if you want to print slash itself. For example, let's say if I'm writing slash here in this line after this e, if I'm writing slash here, and if I try to compile this, so you can see that you're getting error. So it says that unknown escape sequence. So if I write it two times, then I can print the slash successfully. So if I compile this one and now execute this, so you can see that the slash is printed over here, right? So for printing such kind of characters which cannot be printed directly, so in that case we use this set of escape sequences. So you can see this escape sequence and write some program and try to implement by yourself that how the behavior comes out, okay, when you use the escape sequences. So this is one example set that I have given. You can just type this program and execute, and you can observe output something like this. Now the next part is, if I say the C programming language is a free form language, now the question would come that what do I mean by this free form language? Free form language means that I can write my C program in any way that I want, unless I do not break any spellings, or I do not break any syntax rule. So my program would execute successfully. For example, like printf, I'll put one new line, then this string, I'll put in some other line, this semicolon, I'll structure it anywhere, right? So you can observe here that I have not written the programs which is readable enough for human beings, but my compiler doesn't cares about it unless and until I have written my tokens properly. I'll talk about tokens. The program compiles and executes successfully. So this is the meaning of free form language. So a free form language is the one which does not have any restriction that how many spaces you give, how many tabs do you give, okay, and how many spaces you are giving, and where you're writing your symbols doesn't matter. When compiler is processing your particular source file, it should not find any kind of syntax or semantic violation. If there is nothing like that, then the program compiles successfully and even it executes successfully. So that is what I mean by that a language, when I say a language is a free form language, that means the program meaning is unaffected by white space in most circumstances. The statements are terminated by semicolon, not by a new line. So that is important for us. And you can observe clearly that C is not freeform from this particular example. So I hope that you got the clarity regarding our very first C program. The point is that the more we write, the more we practice, the better clarity we will get around the language, right? So that is important for us. So lastly, we can say that C is a very amazing language, and we observed some of the rules, some of the semantics. As we write more and more code, we'll get proper understanding, and that sets our initial foundation of programming in C. So I hope you enjoyed this session. We'll post more regarding this. Thank you.